Welcome. Thank you for joining us today. We're here to talk about FINRA's managed data lake and how we handle the big data analytics in the cloud. So I've got a small request for some of you that have kids like myself. Thought it'd be good to get like a selfie, right? They could actually see me talking. And I'll actually think, there we go. Very good. So before we get into it, we're walking over here and we were thinking about how they set up a conference like this for of this size. And if you notice, you get like in the elevator and it says AWS, and there's stickers on the floor and in the bathroom and everywhere you go. And then we'll leave here on, I think, Friday, and you've got 3 days probably before the next conference comes in. And it dawned on me that this is like a big data problem, right? You've got a lot of work to do, and you've got to do it really quick. So you bring in a lot of people, and you spread the work out, just like you would with Hadoop. And that's what we're finding, and that's what we're looking at doing here today, is how we can leverage some technologies to improve our processing. So we'll introduce you a little bit to FINRA. I'm not sure how many of you know who we are and what we do. Data is central to what we do, so it's a big deal. We'll talk about the on-premise data challenges. So what was it like before we went to the cloud, and how did we make that work? Then the FINRA managed data lake, that's kind of what we built in the cloud and how we got it to work. And then what changes did we have to embrace to move to the cloud? Moving to the cloud is not just taking and lifting what you've got and putting it into a different data center. If you take that approach, I think you're going to miss out on a lot of the benefits. And then benefits of our cloud migration, and then lessons learned. So I'm Tim Griesbach. This here is Rajagopal. He works with me. We're in the Enterprise Data Platforms group, and we're responsible for all the data at FINRA, or we like to think we are. So who is FINRA? So we're the Financial Regulatory Authority, and our job is to monitor the stock market effectively. So we receive about 99% of the equity trades on a daily basis from various sources. We'll talk about that in a minute. And we take that and we end up looking for trying to keep fairness in the markets, as we call it. So trying to make sure that there's not fraudulent activity in various forms. And as you might imagine, this requires a lot of data. As you can see here, we've got, I think our slide might be slightly out of date on this one. We're somewhere in the neighborhood of 20 to 25 petabytes of data that we have in the cloud today. And we get data every day in fairly large quantities. So you'll hear us talk about, in some cases, up to 75 billion records a day that we receive. And then we take that data and we do various processing on it. One of our systems, as an example, I think has 7 trillion records in it that's used for what we call lifecycle analysis. So these are very large data problems, and this is really what drives all of what FINRA does. So if we don't have good data, and you probably heard Werner talk about that this morning, data is crucial to what we do. So we have to have data we can trust, we have to have data that we can track, we have to have data that we can use efficiently, and we also have to be ready to use it in any number of ways. So that's a little bit about what we're doing. So let's walk through a little bit of how we do it, or kind of what the life cycle looks like. So we get data every day from broker-dealers, so that would be the people that you call up to purchase your stocks. We get it from the exchanges, so you've heard of like NASDAQ, NYSE. We get it from reference data sources that give us certain clean data, and all that data comes in through various forms. It may come in through FTP, it may come direct to the cloud, and first thing we have to do is we have to make sure that data is clean. You've got to be able to trust it. So we perform thousands of data checks every day. And Ron will go through more of this and what some of the real kind of detailed numbers are, because those are pretty impressive. And then we do that validation, and we make sure in one of our systems, I think we've calculated we do 500 billion actual field validations per day. So these are big numbers, and you've got to make sure that this is running. It can't stop. We've got strict SLAs around it. So we have to make sure that these things scale. Excuse me. You got a cold, I'm fighting. If you remember, I think it was a couple of years ago, there was something that happened in Europe, and in one day we had a doubling of the volume of data. Now when you're dealing with this size data, that's a lot, and it's not like we get some forewarning to say, hey, by the way, you need to go turn on some more servers. Basically, it just happens, and we have to be able to process that and make sure we can deliver the results. And as part of and along with that, we've also got strict SLAs. So part of what we're doing is on behalf of the, say, the SEC as an example. And so we have to provide information out. Some of it is within hours, some of it's within days, some of it's within weeks. So this gets very complex, so we have to deal with that. So the data comes in, goes through the validation, and the next step is it goes through various forms of ETL or normalization. We do put it into standardized formats that we can then run surveillance is what we call it, but it's, think of like a big SQL statement against it. So we may put it in, we have to ETL it into a normal format, and then in addition to that, we actually build these life cycles. So when you call your broker to order, buy some stock, that then gets handed off to various exchanges and other sources. And in part of doing that, it may be, 5 steps till you actually get your stock handed to you, but it could be as many as 1 million. These, if you're buying large or if it gets tied up in a high-frequency trading, these events get very complex. And we have to be able to stitch that all together to support the business as they're doing the fraud detection. So then the data goes downstream. We track the data, and then we have 2 ways that we kind of use the data today. One is a number of batch systems that process the data. So these are, we've got, I think, 250 plus patterns, and they just run every day or every week and every month, and these are going to continue to run. So these are all run in a kind of an automated way. And then there's also, we've got teams of folks that are looking for new ways that people might be manipulating the market. So these are your data scientists. They're looking at how to use machine learning and develop models that can more accurately detect problems. And then once these batch systems kick out alerts, that will then feed into other business users who are then going to pick up these alerts and go track them down and see if it really is something fraudulent. So some of the examples you've all probably heard of something like insider trading, and that's something that's very common. So they're looking for that, but every alert that we generate internally doesn't necessarily mean that something's been done wrong, so they have to go track that down. But there's many other ways that people manipulate the market, and once they learn how to do that, there's a lot of money to be made. So anyway, so you can kind of see here how this data is used, why it's important, and it's really, we are all about data. Data is a first-class citizen at FINRA, and we have to make sure that we've got good data. All right, so what was our challenge? We're going to go back about 4 years before we moved to the cloud. And we had, we'll walk through a little bit here what some of the challenges were. So if you think of someone at FINRA, they were constantly having to ask things like, what data do we have? And that's it's a question that's still asked today. And it depended on who you knew. If you knew the right person that knew about the data, they might point you at it. If you didn't know, you might actually go acquire the same data a second time and a third time. I mean, that's problems we've dealt with. Or you just might not know the data's there and might miss it. Where is the data used? And what we mean by that is who all's using the data. We get cases where someone may call us and say, well, in exchange, we need to provide you a corrected data set. And so when we get that corrected data, we now need to be able to, as efficiently as possible, figure out what have we done with the old data that they had. How many versions of the data exist? Now, when put yourself in these shoes, if you've been accused of something, you're probably going to want to make sure that, hey, I'd like to see the data that's behind this accusation, and we have to be able to produce that. So knowing where the data came from, who it came from, what we did with it, what processes were run against it, this is all very important. So that's the source of the data, and then the retention policy. So it's very expensive to store data over long periods of time. And so in the old days, it would be pushed to tape and sitting in a tape vault somewhere. But now we're in the cloud. So these are some of the challenges that exist for us today. So this is a little chart here. It's kind of fun. It shows you kind of how it would work. Again, this is in the old days. You didn't know what we had or where to get it. So what would you do? You're reaching out. You've got a business analysts or data science, and they're calling data analysts, and the data analysts are calling data engineers, and they're writing code to say, oh, well, let me go extract some data for you, or oh, by the way, that data that you need is on tape somewhere, and you can't access it right away, so I need to find a way for you to extract it. So this was a rinse repeat over and over. Some of these processes could take weeks or months to deal with. What format is it in? Things of that nature. You can imagine here. And then on top of that was the infrastructure of how we were using the data. So we had physical appliances. So you've all heard of everyone's favorite Oracle, and how many, the beautiful keynote that we had earlier. And then but we also had, we outgrew that, so we went to Netezza and Greenplum. And then we started to continue to outgrow those, and we had a significant investment in these appliances. So a good example of what would happen here is they would say, oh, we need some data loaded from tape. Well, the problem is when you're running an appliance at capacity, that means you've now got to find a quiet period of time to offload a bunch of data, load the data up from tape, do your analytics on it, and then get it back off so that you can now go back to the daily grind that we're dealing with on a day-to-day basis. So sometimes that would take, again, the weeks and months, the delays there. And so that's really what fits into the scale. If you need some extra capacity, you can't just go say, hey, I'd like to buy, a month's worth of a Netezza device. When it's a physical device, you have to acquire and install. Duplication of effort. We also had, over the years, multiple teams at FINRA who were dealing with data. So what you ended up with were lots of these, you've probably heard the phrase puddles, lots of these little applications that would be built up, and each application would have its own little catalog or ways of tracking data, ways of dealing with the data, and that just kind of came out of necessity. That's what happens over time when you have a lot of teams building things. And so now all of a sudden you don't have one place to go look for everything. You've got these multiple data management systems. So that then means you've got multiple places to deal with stuff like life cycles and retention and cleanup and all the ongoing that goes there. Data sync is another one where you had, so if you've got different versions of the data in different systems, are they all the same? That becomes a problem. And then now you're going to try to run analytics across these multiple systems. And so you can kind of see the problems that are building up here. And this just didn't happen overnight. I mean, this is kind of what happens over years of data teams working. And I suspect this is a problem that, I know we've talked to others that have had very similar problems. So these aren't unique to FINRA. I think it's anyone that's been dealing with data over the years. And then costly system maintenance and upgrades. I don't know if you saw, we did some talks last year on serverless. How many people love doing system maintenance? That's the worst, right? It drives all of us crazy that are managing any kind of projects. So it's very costly on teams, it's very costly in dollars. So these are the kind of things that you run into. So we had infrastructure. So what did we do with all this? I think we've talked about process, we've talked about the people, we've talked about multiple teams, and then on top of that's infrastructure. So about 4 years ago, we started thinking about what's next. How do we solve this problem? And obviously the cloud was going, and we felt like the cloud was the right approach, but it was still very early from a perspective of cloud and big data. So we had a lot of challenges. How are we going to do that? So we worked very closely with Amazon and on the EMR and S3, and we use most all of their technologies right now. But the idea was if we could build something in the cloud that would alleviate these challenges, that would be a big plus for us. So as part of that, we kind of list out here these key principles. And these are the things that tried to drive what we're going to do. And I think the first one is the one that we talk about pretty heavily, and that's the separation of storage and compute. So again, rolling the clock back 3 or 4 years, it was unheard of. If you think of Oracle, Netezza, Greenplum, Hadoop, all of them, the processing and the data are together. The catalog, everything about the system is one thing. So if you want to, you're kind of stuck with that whole thing for growth, for capabilities, for performance. And so what we wanted to do was to separate that out and make a big push to say we want to be able to take advantage of the best in storage and the best in compute. And storage is a little bit more mature, but compute in particular, I think in the past 3 or 4 years, Spark really didn't even exist 3 years ago. And now we're converting all of our processing over to Spark. And we're pretty, now with the SageWorks and some of the other machine learning type things that are being announced, we know there's going to be new technologies coming that we haven't even thought about. So the goal is to keep the two separated. Well, the moment you have the two separated, what do you need? You need something to keep track of it. And that's where, and that's the benefit of, like in the Hadoop world or the other database systems worlds, they all kind of have their own little built-in catalogs to it. So we knew we needed to have a catalog that we want to do, and we'll talk about that here on the next slide. But we also wanted to have a single place where everything was registered and tracked. We wanted to make sure that we could go to one place and see what data does FINRA have, and what does that data mean, and how do you use it, even if it was in other systems, relational data stores, in some cases on-prem. When you go to move to the cloud, you don't just flip a switch and everything moves to the cloud when you're talking about this type of scale. So you've got to plan for a couple-year process to actually go through a migration while you're doing that. If we're going to go to the cloud and we've got this capability to keep more data, we want to make sure we can keep all the versions we need. One of the things that happened on-prem that I think a lot of people probably see is they end up not keeping stuff they want to keep simply out of just sheer necessity. They don't have the capacity for it. The systems won't support it. So if we're going to build a new system that can handle this in the cloud, we wanted to make sure we could do that. And then our security team got involved. And they really clamped down on this one. And they said that all data, really everything we do in the cloud has to be encrypted in transit and at rest. So everything that's passing between servers, everything that's stored, and this actually became a limiter in some cases for adopting, in the early days, some of the newer Amazon technologies. We had to wait for them to provide. We do use KMS encryption very heavily, where we manage the keys. So we had to wait till they provided that capability. But again, much of that has evolved pretty dramatically in the past few years. Partitioning data, anybody that's here that's worked with the big data processing systems knows that you want to partition the data in a way that's going to allow you to process it fairly well. So we do that. And then backup, so business continuity. So we don't put stuff on tape, but we do need to be prepared for what happens. And it's one of these discussions you kind of like want to avoid having, but yet you got to have it. What happens if something somehow impacted your data in the East region? It's a scary thought. But so what do is we back it up to another region in a different account. And the idea is that it provides some protection there to make sure that if someone somehow got into the account and the worst thing happened, that would be protected. And the last is optimizing storage processing costs. And we'll talk about this a little bit more here, but what you're going to find if you move to the cloud and you build something like this data lake, these things are constantly changing. The storage costs are changing. The infrequent access comes out. New spot pricing or spot fleet pricing or some new technology. You've got to be prepared from day one to start being able to adopt those, or you're just going to end up where you are today in 5 years, and you really don't want to do that. So these are the kind of the key principles that led it. So we'll start with this here. This is our data catalog. This is the piece that kind of sits between, in our case, the storage and the processing. And when we built this, we also, we really wanted to build it in a product way. We did not want to build another IT project that's, suit for fit for one very specific project. We wanted to build something that we could could kind of grow and expand with us. So we built the catalog. There are several areas of it. The first is a unified catalog. So in this particular case, it's a lot about metadata, schema information, versions, knowing what versions of data we have, the encryption type, how the data is encrypted, storage policies. In addition, we wanted to make sure we could track lineage and usage. So as the system is as data is registered, we track where the data came from, even down to the version level. So that was very important. So to track publishing, consuming. And then a shared metastore. So we've got common definition of tables, partitions. So this is what allows you to work with things like the Spark and the Presto, Hive. It also allows faster to start up clusters. And on top of this, we've added recently in a universal, what we call the Universal Data Catalog, which is a UI that sits on top of HERD. And that's really where we also start to capture business metadata. We'll be adding this to the open source community soon as well. And the idea here is to allow the business users now. So we started with technical metadata. And that's the important, what is the column name, what is the data type, what is the object name. But now we're getting into, what does that data mean? How do you use that data? How can it be used? What is it related to? Things of that nature. And recognizing that now you've got to provide some fairly sophisticated searching and navigation, categorization, taxonomies, things of that nature. And that's really what allows people to now start to, on the business side, be able to start using that data. But we started with this here because we needed to provide an API-first system that all these teams could interact with. And I think Rhonda may talk a little bit about that here coming up because we've got, I don't know the exact number of teams, but it's probably 25 or 30 different teams that are integrated with Herd today. And then because of the way this is built, it allows you to separate out. So now you've got your storage on S3 and different flavors of it. Glacier, it manages life cycles of data. And then the processing's on the other side. And the processing is, as you can see here, we're leveraging a number of key technologies, and we're continuing to add to that. So on this one, if you want to know more about it, you can check us out there on the GitHub site for Herd and learn more about it. So Rhonda's going to come up and share a little bit about, he's on the ETL and processing and kind of getting into the statistics of what we do and how it works and what some of the results we've seen. And then I'll come back and kind of walk you through what was our journey like? How did we have to change kind of culturally to move to the cloud? What were some lessons learned? And then also, what are our next steps?
Thanks, Tim. Hello, everyone. I'm Ranga Rajagopal. I manage the big data ingest and the ETL teams, data dissemination at FINRA. I'm going to go a little bit more details into our ETL pipeline and some statistics and metrics about our processing. So what you see here is our high-level architecture. So I think you saw like a little bit of this in one of the earlier slides. So we get data from 12 equities markets. So our FINRA's main business is like doing surveillance for equity markets and options markets. And to do that, we need data from all of these customers. And we get data from 12 equities markets, which covers about 99% of the equity data in US, and about 4 options markets, which is about roughly 60% of options market data volume in US. And then we get data from other third-party providers and industry providers like SIP, and our FINRA's broker dealers also send us data, 4,000 plus broker dealers, they send us data. All of these data, the approximate average volume on a day is about 30 to 35 billion transactions. And all of these come into our ingestion platform. The first thing we do is we register the source in our data management platform, which Tim mentioned about a minute ago, and it's copied to S3. So S3 with data management on top is our data lake. So all of the source gets in there, and then we have an automated notification process that triggers, which is again supported by Herd, and which triggers our validation, where we run about 500 billion validations on these data, and we normalize these data. We do a lot of linkages, aggregations, and we basically generate more like a cross-market model, which helps a lot of our internal applications do a lot of advanced surveillance, analytics, a lot of other analysis. And the technologies that we use is Spark. We use EMR a lot of EMR with Spark, Hive, machine learning, Presto, all of these are used. And once the data is processed, again, all of our processed data is back, put in S3, registered in our catalog, and made available to all our internal applications and external applications to consume them. We are very tightly integrated with AWS IAM policies for security groups and security management, and encryption is very important for us, so we are fully protected with the KMS encryption for all of our data. Again, a little bit of the details here. So we have one data lake. All our data is in one location, one S3. There is no like duplicate data sitting out there. In our on-prem world, we used to have multiple copies of data, so we don't know like which customer, which application is using which copy of the data. So here, everything is one location, one source of truth, and used by all of our multiple applications. The one on the left is our web-based UI application, which reads about billions of transactions every day to provide audit trail information and uses Presto on the back and talks to the S3 and our data management from the data lake. The next one is actually our SQL-based data surveillance model, which does surveillances like market manipulation, code spoofing, those kind of surveillances, and primarily SQL-based and runs Hive and Spark. And these are actually like more batch-based jobs that are probably running about 300 to 400 of them every day. The next one is like which we started doing in 2017, late 2016, early 2017, we are trying to migrate a lot of our models that are more SQL-based into like a machine learning models. And again, we built our own universal data science platform, which provides Jupyter Notebook capabilities, RStudio, Python. Again, those are also running against the same data lake, same data source. We have an ad hoc SQL platform, which is powered by Presto, primarily for our data analysts, business analysts, and power users who are very SQL savvy, and they can actually use that and to run their SQL analysis on any data questions, any data quality questions, those kind of things. And then I think Tim also mentioned about our Lifecycle viewer. Whenever an order comes into a system, like an equity order, any buy or a sell order, it might like get executed in like one transaction, or like in some of the big orders, it could actually even have like close to 1 million events. It can be split into multiple orders. It could be routed to a lot of locations, and like so the whole life cycle is built using HBase on our side, and again supported by our same S3 data lake. So that's a very high-level view of our data lake, supporting all different kinds of our technologies on the top and applications. A little bit more details on our data science here. So we have EMR. We have our data science platform supported by EMR with Databricks, and we have our universal data science platform. Everything used by our data analysts, data scientists, using like an ad hoc mechanism, or using notebooks, or like an RStudio like IDE, and then they use all of these technologies and still go against our universal data catalog and one copy of data and run all their models and all kinds of surveillances. So now let's talk about some results that we got based on our cloud journey and our cloud migration from our on-prem environment. So before we moved to the cloud, I think, as we said, like there are multiple copies of data, and if an upstream customer changes the data, and we have to basically make those changes in multiple places, and it's very difficult to track. And some of the data, if we have to change a older data set, which is not currently in our database, we probably have to go back to the backups and get them back, do those updates. So it is definitely a lot of operational overhead, a lot of manual process. So with our cloud journey, with our cloud migration, we have a better data management. Like we have our own open source herd data management catalog, and then we built a very standard data processing pipeline, which is completely automated, a notification triggered. So a data comes in, a job kicks off, and then it delivers an output. Another job kicks off. So it's a very well-managed pipeline and very easy to do reporting and investigation. Most of the things that our businesses do is like a lot of investigation support for examinations and other things. So very easy to do those reporting and investigation. And of course, we are moving into all of the AI and data science, machine learning. So very easy to do those. So instead of multiple copies of data, now we have like one copy, one data source, all in S3. A lot of cost reduction and highly secured. And at the same time, we are a regulator, so we have to be compliant to a lot of rules. So it also meets all of our required regulatory compliance. Some usage statistics on our AWS. So this is something that we took, I think, for the week of May in 2017, where when we run our EMR jobs, how many EC2 nodes we are bringing up and down. So we are completely transient, so we don't have permanent clusters or permanent EC2. So we bring up transient EMRs with EC2s, and then when our job's complete, they're shut down. So on this particular week, on a peak, I think we had about 33,000 EC2 nodes running for all our batch processing and analytics jobs. And 93% of those were mostly Spot. For those of you who doesn't know how Spot works, AWS allows you to do bidding for your EC2 instances. So in this case, what we do is, if you are actually trying to run a job, let's say for 3 hours, and if it requires 50 nodes, if you go and do their on-demand for the type of machine that we are using, maybe I'm thinking, like, I'm just making a guess here, it's probably be roughly $2 and then per minute, $2 per hour. So for 50 nodes, if it's going to run for 3 hours, we're probably talking about $300. What we do is, like, in our Spot pricing mechanism, we bid, like, when we run our jobs, we bid for those missions, probably anywhere from 10 to 50 cents. So instead of $2, even if we are paying the max 50 cents, we can probably finish the whole set of job, which could have costed $300, probably for $75. Again, I'm only talking about one job here. So we are running about 1,000 jobs per day, and then you can actually calculate the savings that you would get in the entire year. So there is a lot of like savings that we get by doing all of our jobs in Spot, and it is very useful for people that can actually like run bad jobs and restart them when they fail, and for those kind of things, Spot is very useful. And then again, our storage is it's growing. We have about 20 petabytes of data in S3 and Glacier, and it continues to grow. Again, another stats on our dynamic processing. This was taken, I think, in November of 2016, where we are trying to see how our system is automatically scaling when volume increases. So as I said earlier, our average on a daily basis is about 30 to 35 billion transactions. And then on this day, suddenly our transaction peaked to 50 billion. In our old on-prem world, the same thing would have happened. I think some operations DBA, someone is sitting there trying to move the disk, free up the disk space, put something in the backups, all those kind of like work has to happen because the market volume is increased. When you're in cloud, running on our EMRs and S3 for storage, we didn't do anything. It automatically scaled. Instead of running for 50 nodes, we ran in 100 nodes, and then everything was fully automated. So the whole day, went with, like no problems, no SLA issues, nothing. Everything ran, as per our schedule. And as you can see, throughout the day, our EC2 instances are going up and down depending on our usage. And again, same story here. All of them were running on Spot, which means, like even if the market volume is increasing, we are still running on Spot, and we are saving money in all our batch processing. On the data growth, so FINRA's data is growing day by day. So one of the things that we have noticed is, even if our data is growing and like petabytes of data we have in our S3 and Glacier, we are still saving cost because AWS is reducing the price of S3. So while the data is growing, S3's price is dropping. So on a whole, we are saving money. So if we are an on-prem, if our data is growing, we might have to buy additional disks. We might have to do a lot of backups. So a lot of operational overhead is there. So here, the data is growing. We don't do anything to manage it. Like S3 helps us to automatically manage it. And then we are also saving the cost. So that's interesting. Something on our query speeds on for SQL. So as I told earlier, we run Presto for our ad hoc SQL. Most of the files that we get, we keep like 2 copies. One copy in like a bzip text format, more for backup and retrieval. In case we have to do some business continuity retrieval, we can take the text copy and then do any processing that we want in the future. And for all the performance type copy, we use like ARC and the Parquet compressed storage format. So here is an example of how ARC and Parquet performs for a normal SQL type operation. So we have a table where it is partitioned by most of our tables are partitioned by date, partitioned by date. If you run these queries against just our regular text BZ version, it's going to take about a minute or 2 to get the results back. But in this ARC or Parquet compressed version, it comes back in seconds. And this is the platform that's primarily used. Most of our data analysts and power users, they use this primarily to do a lot of SQL operations for any kind of data questions or anything that comes up. So we run this on Presto, and then the data is actually staying in S3. We don't copy the data into any HDFS or anywhere, everything in S3. We create external tables on top of S3, and it runs on we have about 60 nodes on an R4, 4x large type missions, and this is what is primarily supporting our interactive querying. Some benefits here. So as I said earlier, like our analysts and users can easily look at billions of records and market events that's coming in because we have all the data in our system now. In the past, when we had our on-prem system, we could only keep like certain days of data. Like there is a data set that I still remember, which is about roughly 15 billion transactions per day, or about 10 to 15 billion transactions per day. In our old world, we could only keep like 1 week worth of data. And if a user or business comes to us and says like, hey, can I get the data for like some last month? We have to move this 1 week of data out and then put the other 1 week of that last month's 1 week data and then give them the answers. And then if they're asking for like some 4 weeks of data, we have to do this 4 times. Now, in our new world, this same data set, which is roughly about 10 billion transactions per day, we have the data for 2 years in our S3, and we can actually provide answers to the business on this data set for 2 years worth of dates. So again, that's one of the biggest benefits, like by moving to cloud, S3, our data lake. So that's a big benefit for us. On the next one, then one of my other favorite one is the reprocessing. So because we are in a lot of data-related business, we do have reprocessing happening. Things happen upstream to us where there are changes to the data, things happening internal within FINRA where there are some changes, in which case we may have to go back and reprocess this data. So most of the times, the reprocessing in our on-prem world before was very expensive and a lot of time consuming. So I wanted to give an example, which I still remember when we started the cloud journey about 3 years back, and I think 1 year into the cloud journey, we got a request to reprocess one of our big data sets, which is about roughly 5 billion transactions per day. It had to be reprocessed for 2 years because the business wanted to rerun some models based on the updated data sets. We were just thinking, like, if we had to do this if the same request we had gotten from our business in an on-prem world, it would have probably taken us maybe about 3 to 6 months with a lot of juggling around and moving the data out, moving the data in, a lot of things. In this case, we processed that entire 2 years of data over a weekend using our spot processing, spot pricing mechanism in EMR, and we probably would have spent, I would say, roughly $20,000 total. If we had to probably even put I don't even know how much it would have costed on the on-prem world, but roughly it would have been anywhere above $100,000 to $200,000 for sure. But I don't think we could have even completed it because there is no way we could have completed 2 years worth of reprocessing in our on-prem environment without like creating more space, which is again expensive. We need to buy disks or move things to the backups. So we need to basically get the restore from backups. Very lot of operational overhead. So again, as I said earlier, when the market volume changes, no disruption, nothing happens, everything runs smooth and always, our systems are always, like up and running, better uptime. And as it says here, our total cost of ownership for it is definitely 30% less than what it would have been in our data center. So that's some of the benefits. Now Tim is going to come back and talk about some of the organizational changes and some process benefits that we've gotten by the cloud journey. Thank you.
Great. Thanks, Ranga. So that's pretty amazing. I think those numbers that you see there are staggering at times. I mean, you think 25,000 servers a day? What kind of data center would that take to run that? Being able to reprocess stuff for $20,000 and to get it turned around quickly, storing the volume of data that we've got. The results we've seen are just unbelievable, and it's been from top down at FINRA. Folks have been impressed by it, and they've seen the benefit of it. They're doing things today. Here's the other interesting thing. So when you move to the cloud, you're thinking, we're just going to take our existing stuff and move it to the cloud. Well, all of a sudden, you get to the cloud, and we realized, well, folks are doing 10, 20, 30% more. They're actually asking harder questions. They're processing more data, because it simply wasn't possible before. So it's interesting to now talk a little bit about how we got there. So the benefits of getting there, and the how we got there, there's a ton of benefits that come out of the how we got there, because we actually went through a cultural change internally. How people work, how people think and approach building software, and this is a big part of it. So we'll start with the first piece. So again, we'll go back 3-4 years ago. To be honest, not many people at FINRA knew much about the cloud. I mean, I think they knew what it was. A few people had run a few web apps. This is kind of the basic hello world type thing. But really to build production level, high SLA, high performance applications in the cloud that are secure, didn't do it. So we had to figure out how do we go about doing that. So we reached out, and the first thing we did was reach out to some of the big name big data vendors at the time and consultants, and they came in and met with us. But we realized this can't be done with outsiders. This has to be internal to FINRA. Our engineering staff's got to own this. They've got to own how it works and why it works the way it does, the architecture of it. So we made a big push to actually have folks start going into self-study, working with Amazon, working with others, building experiments. You hear that a lot in the cloud. Just start playing with these technologies and see how they work, and you learn a lot along the way, because when you read the the Hello World part and the intro guide on these technologies, it's interesting, but then when you actually put it into practice, you start to learn some things, whether it's latency and some other, especially when you're dealing with big data. And then we also leveraged AWS product support. That's been very helpful. But along that way, we've transformed the knowledge inside of FINRA, and I think it's probably not arguable that today we've got many cloud experts resident at FINRA across the data, the whole spectrum, whether it's infrastructure, whether it's DevOps, whether it's how the actual technologies themselves, the EMRs, the ones that we listed up there. There's so many of them, it just goes on and on. So it started with knowledge. And then we got into the way we structure our teams, and the way we build software is going to have to change. So everybody here that's got an on-prem data center has probably seen this, right? You've got a development team, and they need to make a change to a Unix box. Do you make the change to the Unix box? Probably not if you've got a production system. So what do? You put in a ticket, you call the SSE, the engineers, the Unix folks, they log in, they make the change. By the way, they make the change like 3 or 4 times. And do they always make it the same way 3 or 4 times? Maybe not. You come to find out later when it's in production that it wasn't. But this is just the way we all worked prior to the cloud. And as part of that, we realized we wanted to integrate kind of the systems engineers and the app dev teams. And you've all heard the DevOps culture as well. So that now you've got the teams own that, and they're responsible for it. But you still need this, as we kind of depicted here. You need someone that's a Unix expert. You're going to need people that understand some of these technologies that can be consultants back to the team and actually provide feedback. But they don't own it. The team has to own this. So that's the first before and after. And then the infrastructure as code. It's kind of in the same theme here, where the team owns it. So we talked about calling the sysadmin. Can you change something for us? And now it's all automated. Our focus is to automate everything. We actually are one of my groups just finished, is in the final stages of migrating a fairly big system to the cloud. And so as we get it to the cloud, everything they do, everything about it is automated. The way the infrastructure stood up, the way it's configured. So now if you have a problem, you know where it is. You can see it. You can see the code itself. You can go look in GitHub and see the changes. You can run it in a QA environment and then be fairly confident it's going to work, because you're going to take the same code, and I mean the infrastructure here, and actually run it in the production VPC. So this was a big change. And these aren't, it's a simple picture, but these aren't simple changes. It's going to take some time to work through that. Some of it is you're going to have to change processes. Many of us have got, organizations where things are audited, and we've got different, there's different folks plugged into it, and they're not just, we have to work through actually coaching them on that change. And then that's continuity of service across the ecosystem. So I mentioned this earlier. You're not just going to snap your fingers and migrate 20 petabytes of data and 500, or 500 is probably not right. I think we've got probably 100 different systems, but hundreds of different things that are running every day, or thousands, to the cloud overnight. You're going to have to do this in an incremental way, and that's part of what the cloud drives. Build one thing, get it working, get it automated, make sure it's right, and then add to it. So because of that, you're going to end up with a hybrid here. You're going to end up with some data in the cloud and some still on-prem. And your on-prem systems are probably mission critical, so they can't just break. You're going to have to honor that. So in our case, we built a bridging system that would, and data is our world, right? We're all about data. So if there was data being processed in the cloud, we would bring some of it back. If we were processing data on-prem, we would bring that out to the cloud. So because we were running processing on both the systems, and we needed to be able to do that without them breaking. So we had, this is probably a big piece here that you'd have to think about. And in our case, I think it was about 2.5 years that we were running it like this. And now we're 100% in the cloud on this, with this particular system. So what lessons did we learn, and what's next? We'll kind of touch on this here a little bit. So this first one, this is where it gets a little bit dicey when you're trying to get into this. Disrupt legacy practices. If you take what you've got, processes, tools, organizational structure, and move it to the cloud, I would say you failed. It's not what it's about. This isn't taking it from one data center to another. This is about changing how you work. And that really drives through the culture of everything you've got. So automate, automate, automate. Our goal is we want everything. So Herd is an example. I'll brag about that because it's one of my groups. It is 100% automated, 100% unit test automated, 100% code, 100% QA test automated, everything. They run Chaos Monkey with it internally. The point is that when they have changes and they want to deploy them or push changes out, they've got a very high degree of confidence. When I go to the engineers or the managers on the team, they're not, you go to some teams and they're a little bit nervous. You can kind of see it in their eyes, like, uh-oh, I don't know, I hope it's going to work. And that's what you want to get away from. Transform people and processes. You're going to have to think about things differently. And so this is kind of that opportunity to do that. That's how we approached it. So this took time. We went all in on Agile. I don't want to say Agile is the panacea that solves all problems, but there are tenets of Agile that were big for us. Things about traceability and accountability and the team involved, they're all part of it. The automation is a big part of it. This was all a very big part of it. We've integrated our teams, so now we have teams of engineers. Automation is code, right? So you need people that know how to write code and know how to, and then and their goal is to break things and to own that. So you want them to care about it if it breaks. This isn't like, well, that's their problem. This is our problem. If this thing breaks, I want to know about it, and I need to deal with it. Reporting, that monitoring, that type of stuff. Continuous improvement. So this is a fun one. The cloud is, I don't know, that I was surprised at the number this morning. He said something like, I don't know how many thousands of changes they've released in 5 years. But you can't keep up with it all. But if you don't adopt any of it, in a year, you're going to be so far behind. And that's really, again, you're going to be just where you are today, where you're kind of sitting there, kind of plugging along a little bit. You want to be in a mode where you can adapt these changes, take these pieces, take these enhancements, whether it's new technologies, new features on those technologies, new servers. So let's use a server example, EC2. So one would think, a whole new server family is a big deal to retest. Well, it is if you're kind of living in the yesterday. You got to go, but if it's just let's fire up one of these environments and run our automation on it, hammer it real hard with load testing, you should have a pretty high degree of confidence in that. And it doesn't turn into a 6-month project to adopt a new EC2. And this last one here is, for those of you that are budget-minded, CapEx to OpEx. So what we do, so now you're treating it as OpEx instead of CapEx. So what does that let someone like myself do? I've got a team that comes to me and says, hey, Tim, I think if we spend a little bit of money here and do some engineering, we can actually reduce the spend. We can optimize this process, so instead of needing, and this just happened this year, instead of needing 1,000 servers to run on an EMR cluster, we can reduce it down to 50 servers that run over 4 hours, and it saves you, cuts the cost in half in this particular example. But it's going to take some engineering work to do that. Well, because of that, because of the way we are managing our teams and our budgets now, I have the flexibility to go in there and say, I'm going to take that investment, what I know is going to be originally, say, budgeted for non-labor, and I'm going to spend that on the R&D because I'm confident, and I've met with the team, and that we're going to get that reduction out from that. And then years 2, 3, and 4, you've got that production there. So this is big. You've got to. It's a different way of modeling and managing what you're doing. So I think that was. So the next is what's next for us, in case you're curious. We probably have to add to this slide, to be honest with you. After some of the announcements from this week, everything around the EC2 pricing and the the EC2 templates. Some of these are capabilities that we've built into Herd that we may end up retiring because we may say, we don't need to do that anymore. We can let Amazon do that. So here we've gone through with some of them. Spot fleet's a big one. We have a challenge because we run about 1,500 clusters a day, and the number was, I think, 25 to 50,000 servers. If we get a cluster that it used to be that we would run a cluster and it would get, an hour and a half into the job and it would get taken away from us. Well, that's money we've spent, at least the first hour is. And so now we've got to start another cluster, and it might get an hour into it and get taken away. And then our systems are automated to where they would say, okay, we're not going to do spot anymore. We're going to, now after the third time, we're going to go and run on demand. So there's new capabilities in pricing that are going to help alleviate some of that for us. So we're looking to leverage that. Amazon Athena. Serverless is a big deal. As I said last year, if I could get out of having to upgrade AMIs, I would do it completely. It's painful. And when you have more and more systems and more servers that you've got to deal with, it's just this churn that's just taking away from building new features and value. So we're constantly looking at how we can use Lambda. In this case, we've got Athena up there. They're not all perfect, so you're gonna have to look at them closely. Broader adoption of Lambda. In our case, there were some security issues early on, but those have been resolved, so we're starting to use it more and more now. And that's a plus, and they scale, as you can see here. I love that number, $500 billion. As I shared, I was telling a colleague, I did the math last year, and if you take a Lego's, I think, 2 inches? $500 billion, so 500 billion Legos would wrap around the world like 5 times or something. It's some insane number. So, that's a lot of processing that we're doing. Machine learning and AI. Look at the announcements this week. We're already realizing, another colleague said, I think we need to change and do all our road mapping after reInvent. And I think that's true. I think we're going to have to go back now and reevaluate some of these things because there's a lot of opportunity there. Step functions for orchestrating processes, where it's something we're looking at doing. Multi-region support. This is a fun one. So when we first started this, we thought US East. So the rule was, and my apps are this way, as long as US East is up, the apps have to be working. And we thought, well, that would be pretty dramatic. I don't know, for US East to go down, it would have to be some really horrible event. Well, this is software, right? None of us are perfect. And something happened earlier this year, and there was an S3 outage, and I think it's safe to bring it up because everybody knows about it. But that impacted us. So much to the point that it went all the way to the top of our organization because we have SLAs and rules around dates, and it happened on a day that something was due. Well, that's a big deal when you're a regulator because they're concerned about getting fined and everything else. So now the question is, there are certain systems that can't go down if possible. How can we make that even better? So multi-region, you may not need to do this for everything. I thought Werner this morning did a nice job. He was talking about how, look, there's some systems that don't need 5 or 6 nines availability. But the ones that do, you need to think about how you're going to build that. And then AWS Glue integration. We've worked closely with the Glue team since they created it. I think it's a couple years ago now. But we want to integrate that. It's a very critical kind of operational metastore that drives all of some of their systems like Athena and QuickSight and some of these things. And we want to make sure that our catalog, the Herd catalog, is integrated with it if possible, so that we can kind of keep it up to date. So we've got some new things here. And then of course that the last line there, continue to monitor what's coming. Look, this changes monthly. And it doesn't mean look, we're not going to drop everything we're doing every time they announce something new and jump on it. But you've got to have some discernment. You look at it, you see which things may be strategic for you. Do a POC with it. When they first come out, it may not be ready for you. And then kind of go into there. So that's what's next for us. So I think at that point, that's kind of about it. We love what we do. We have solved some amazing problems. And we hope that this helps a little bit maybe on your journey as you're thinking about it. I know that I think we've got about 5 minutes, 4 minutes now as I look at the clock. It's ticking down rapidly. So if you have any questions, we're certainly happy to take them.
As a regulatory body, did you guys have to concern about vendor lock-in when you first looked at AWS Cloud, and did you you went all in, of course. What were your thoughts around how you navigated that in terms of being stuck with AWS, or would you have to move out in future or anything of that sort? Or?
Right. So there are some cases where we have created some independence there, but I think the reality is that our goal is to provide value, be a better regulator, and so we need to make sure we're providing the features that drive that. And so if you don't leverage some of these new features, the speech to text and the stuff that's come out this week, this is stuff we want to start leveraging. Or not speech, I'm sorry, the text analytics. That's also cool. Everyone's, we've already got people with the cameras, and somebody said you could train it to recognize a hot dog. I don't know if right? I don't know if anybody tried that, but someone on our team apparently did that. So our goal is to be a better regulator, provide more value, make sure we're doing that. So there are some cases internally where we talk about it and we think about how closely tied are we, and are there cases where we want to keep it separated.
Can you throw some light on how you guys handle schema enhancements? Like you get a lot of files from the agencies, so somebody changes the files. How your process keeps track of it? Or at least not tracking of it, not versioning, but like accessing, giving access to the users with different layouts.
So the tool that we use, the Herd data management, we register the DDL with all the objects that we register there, and also it is also versioned. So every time like a column changes or some attribute changes, it is versioned. So the first thing that we do in our jobs is get the DDL out. So there's an API call which basically gives the DDL out. It is on Hive DDL right now, but we're planning to provide other DDLs also. But that's what we use for managing the schemas. Does it answer your question?
That will end up as a new data set in your lake?
Yeah, if there is a new version comes in. Yeah, the schema is more at the format level. So it's not a new data, it's actually new schema registration. But if a new data comes for that schema, there will be a new version of that data. So we have versions both at the schema level as well as at the version data level. So both are versioned.
We do have, so Herd has, one of the features it has on the schema side is that versions of the schema must be backwards compatible. And this is important for the tools that rely on the schema for processing. If they're going, and that's what we call a format, so that defines the format, what columns, what the data types, things like that. if you're going to bring in if you're going to dramatically change it around, it may be a new format or in that case a new data set. So we do have cases of both.
I had a question of architecture. Did you change your ingestion architecture with the cloud, or do you rely on the same ingestion architecture that you had on-prem?
I think we do a little bit of both. So we have folks that give us data via FTP or SFTP, and that comes on-prem, and then it's immediately shuttled up to the cloud. And then we have some folks that are giving us data directly to the cloud now, and then that triggers the actual ingest process, the beginning of it, once it's in the cloud. We don't do, I mean, anything that comes on-prem, there's some legacy, so we have some cases, for example, where people might have a dedicated pipe between the broker-dealer and FINRA for security reasons. So they still use that, and then we shuttle it up to the cloud. But all the processing is in the cloud. So, no, it's all built new in the cloud. So they're using a mixture.
We rebuilt like completely brand. We didn't use the same things that we did on-prem. So completely rewritten in Hive, Spark, MapReduce. So completely new sets of code.
Was your data bridge that you used to transition from on-prem to the cloud, was that custom code or did you get something out of the box?
So we have two things there. One is like as part of our data management herd, we have an utility called DM, Data Management Uploader. So, and then we wrapped around our own custom code on top of that, which is basically like something that's a job that's scheduled, like every night to, like look at the data that's coming in on-prem in an FTP location and then just bridge it. And then same way, if something is registered on S3 and if we have to bring it back. And this is again only when we had to deal with hybrid during the initial times. Now we are 100% on the cloud, so now we don't use data bridge at all. So, but when we started, that's how we used data bridge. Yeah.
Okay. Thank you.
Thank you.
I think our time is out. So really thank you all for coming.
Thank you all.
We'll be around for questions if you have.